Hello everyone, I'm Helia Homami. I'm a master's student at Dalhousie University, Halifax, Canada. And today I'll present our study on omnidirectional VR treadmill walking techniques, comparing walking in place and sliding versus natural walking. This work was done with my supervisors, Dr. Adria Quigley and Dr. Mayra Barrera from Dalhousie University. Walking is essential in VR applications such as training and rehabilitation, as it enhances immersion and spatial awareness. While natural walking provides the best experience overall, it requires larger spaces, which limits its visibility in most VR setups. VR-Omnidirectional treadmills, or VR-ODTs, offer a solution by enabling movement in small spaces. In previous research, like Chakraborty et al., they compared VR-ODTs to natural walking, showing negative effects on path integration and increased walking distances. In another research, Hooks et al. In 2020 evaluated user experiences with VR walking simulators. However, few studies actually directly compare walking in place and sliding within VR-ODTs. So this study fills that gap by exploring their effect on navigation performance, user experience, and physical exertion. We aim to answer three key research questions. How do different VR locomotion techniques impact user performance and user experience? And also, what are the physical exertion differences between these techniques? These questions are important to determine which techniques are best suited for VR applications like training and rehabilitation and immersive experiences, while also addressing gaps in previous research. We evaluated three locomotion techniques. First was walking in place using CAT VR Mini, where the user moves the legs like walking but does not move. And the second one was sliding using CyberEarth Virtualizer Elite 2, where the user gives a full step but then slides back to the initial position. And lastly, in natural walking, users freely walk in an open space. We believe that each method presents different challenges and advantages in VR navigation. We conducted a within subject study with 18 participants, 9 men and 9 women. Each participant navigated a 7x7 VR maze with 4 randomly placed spheres in 8 fixed boxes, using all 3 locomotion techniques, each twice. We collected data on user performance, including trial duration and distance traveled. We measured physical exertion through step counts and NASA TLS scores. We also collected data on usability and user experience using SUS and VRSQ questionnaires. And for user preferences, we did it through a post-study questionnaire. This video shows a participant using the walking in place technique to navigate our maze. They have already found 3 spheres and are now searching for the last one before exiting the maze.
4.
This video actually demonstrates how users interact with the environment and move through the virtual space. They're now searching for the exit. In the following slides, we can see the results. We measured a total distance traveled and trial duration to evaluate user performance. Natural walking performed best with a significantly faster completion time and also shorter travel distances. Next, it was sliding that was slower than natural walking, but still faster than walking in place. And walking in place was the least efficient, which required significantly more time to complete the task. Total maze exploration did not differ significantly between locomotion techniques, which means all users explored a similar number of maze cells, revisited boxes, and empty boxes. And this suggests that locomotion type did not impact the ability to explore the environment. It was just how efficiently users moved. We evaluated subjective usability scores. Natural walking was rated the most natural and immersive, as it felt intuitive and it's the closest to real life walking. Then it was sliding that was highly immersive and received positive feedback as an alternative to natural walking. And next, it was walking in place that received the lowest usability ratings in SUS questionnaire because of its unnatural movement and also high effort. Overall, sliding and walking in place both were perceived as alternative to natural walking as they reduced in concerns about real-world collisions. To evaluate physical exertion, we measured NASA TLX scores and steps taken. Well, walking in place required the most effort, confirmed by its higher NASA TLX scores and also user feedback on fatigue. Sliding and walking in place both required more effort than natural walking, and so natural walking had the lowest physical demand. That aligns with prior studies showing that real-world walking requires less effort than VR treadmill-based locomotion. Limitations. The results of our study depend on the VR-ODTs and interaction technique we used. So obviously different hardware can affect performance and user experience. Although our sample size was diverse, its small size limits the generalizability of our findings. And lastly, our step counter affected measurement consistency, so future work should explore more reliable step tracking methods such as sensor-equipped shoes. To conclude, our study compared 3 VR locomotion techniques: natural walking, sliding, and walking in place. Natural walking was the most efficient and preferred method as it provided fast navigation and low exertion and high usability ratings. Next, it was sliding. That was a strong alternative because it offered a good balance of immersion and a moderate effort. But in converse, walking in place required the highest physical exertion and received the lowest usability ratings. So it was less practical for extended VR sessions. We found no significant differences in navigation efficiency between locomotion techniques, which means regardless of the method, users explored the maze similarly. And overall, our findings suggest that choosing the right VR locomotion technique depends on the intended use case. Thank you, and from now on I'm happy to take any questions.